Hello dear student, I am Manoj Islam. Today in this video we are going to discuss an important question from CSIRNET June 2021. Okay, this question from part C and question ID is 526. Okay, in this question the three system equations are given. Okay, and it asking for which values of k the system is consistent. Means consistent means the system gives solution. Okay, for the system solution exists for what values of k. Okay, and giving the values of k maybe k 1 2 minus 1 minus 2. Okay, so we are going to check each option one by one. Okay, so for I'm checking option 2 first. Okay, for k equal to 2, for option 2 k equal to 2, put k equal to 2 into given system. If you put k equal to 2 in a given system, so you get 2x plus 2y equal to 0. Okay, first equation gives 2x plus 2y equal to 0, right? So this gives x plus y equal to 0. Name it 1. If you put k equal to 2 in the second equation, you get 2x plus 2y equal to 2. Okay, so it gives x plus y equal to 1. Okay, so x plus y equal to 0 and x plus equal to 1. So see in this for equation from equation 1 and 2 we get x plus y equal to 0 and it gives x plus y equal to 1. So 1 and 2 will imply 0 equal to 1, right? Because both left side are equal, so right hand side should be equal. Right side should be 0 and it has 1, so 0 equal to 1. But it is never possible, it is contradiction. Okay, so values of k never be 2. So option 2 is incorrect. Okay, so values of k never be 2. Now choose the values of k. Choose the value of k minus 2. Now I am going to option 4. So option 4 given k equal to minus 2. If I take k equal to minus 2, okay, then what gives? Then see, first equation gives 2x minus 2y equal to 2 minus 2 4. Okay, 2x minus 2y equal to 2 minus 2 4, and the second equation gives 2x minus 2 equal to 4. So this gives x minus y equal to 2, right? Name it equation 1. And second equation gives minus 2x plus 2y equal to minus 2. So this gives x minus y equal to 1. Name it 2. Okay, so from 1 and 2 we see that both left hand side are equal, so right hand side is equal. Right hand side of 2 equation 1 is 2, and right hand side of equation 2 is 1, so 2 should be equal to 1. Okay, so from 1 and 2 we get, you can write like this, 2 equal to x minus y, and x minus y in this equation 2, from equation 2 we get 1, so 2 equal to 1. But it is not possible, 2 never be equal to 1. Okay, so it is a contradiction. So values of k never be, the value of k never be 2. Okay, so option 4 is incorrect. Now the left value are k equal to 1 and k equal to minus 1. So we are now going to check for k equal to 1 and minus 1. Okay, you choose k equal to 1. If you choose k equal to 1, so first equation becomes 2x plus y equal to 2 minus 2 1. Okay, name it 1. And second equation becomes x plus 2y equal to 1. Second equation, name it 2. Okay, and last equation becomes y plus z equal to 0. Third equation. Solve this equation first and see there are 3 equations. Okay, first, second, third, and there are 3 unknown x, y, z. There are 3 equations and 3 unknown. Yes, so number equation and number unknown. So this equation is unique solution. Okay, this equation is unique solution. And now we are going to find the solution. So solve first 1 and 2. Solve 1 and 2. Do one thing. Multiply 2 by 2 and subtract from 1. Okay, if you do this, what do you get? 2x plus y equal to 1. You get 2x plus 4y equal to 2. Subtract with minus 3y. Minus 3 equal to minus 1. So y to be equal to 1 by 3. Now if y equal to 1 by 3, then third equation you get z equal to minus 1 by 3, because z equal to minus y. Okay, z equal to minus y, so z equal to minus 1 by 3. If you get y, then from first equation or any second equation, put any equation values of y, you get the values of x. Okay, so I am putting in first equation y equal to 1 by 3. If I put y equal to 1 by 3, so I get y 2x plus 1 by 3 equal to 1. So this gives 2 is equal to 1 minus 1 by 3, right? So this gives 2 by 3, so this gives x equal to 1 by 3. So x equal to 1 by 3, y equal to 1 by 3, z equal to minus 1 by 3. So we get any solution, right? For k equal to 1, we get any solution. For k equal to 1, we get any solution, and the solution is x equal to 1 by 3, y equal to 1 by 3, and z equal to minus 1 by 3, right? So for k equal to 1, we get any solution. So for k equal to 1, the solution is the system is consistent. Okay, means the system is any solution. The system is consistent. So for so option 1 is correct. Okay, you can also go through the rank method. Okay, in this method I am using no concept of rank method. It is basic concept of element class element. Now I am using k equal to 1 and using the rank method. Okay, you can also proceed this method. So you have to consider basically argument matrix. If you go through the rank method, you have to consider the argument matrix AB. Okay, so first if you try A, for A, if you k equal to 1, then 2 is first, it gives 2, then it is y coefficient is 1, so 2 1, and y z coefficient is 0. Okay, so it gives 0, and for the second last k 2 minus 2 is 2 minus 2 is 2 minus 1 is 1, so 1, and for second equation it 1 minus 1 0. Okay, for second equation k equal to 1, so it gives x coefficient is 1, y coefficient is 2, z coefficient is 0, it is 0, y coefficient k is 1, and z coefficient is 1. Okay, so this is the argument matrix. So to make it 0, okay, if you have to convert it to Rocklin form, so you have to make it 0. So apply the operation 2 minus 1. If you apply the operation 2 minus 1, this gives 0, 4 3 0, 2 minus 2 1, 2 1 0 1. Okay, now this will let. Now apply the operation 1/3 R2. If you apply the operation 1/3 R2 on this 1/3 R2, okay, if you apply the operation 1/3 R2, then you get what? You get 2 1 0 1 0 1 upon 3 0 1 1 0 1. Okay, now you have to make it 0. Okay, so subtract R3 from R2. You subtract R3 from R2. If you subtract from this R3 to R2, okay, so what I get? I get 2 1 0 0 1 0 0 0 1, and this is 1 1 by 3 minus 1 by 3, right? So this is basically A matrix, and this is a B vector in this case. Okay, AB. See, this is upper matrix. Okay, upper matrix, in case of upper matrix, diagonal entry iron value, so 2 it iron value are 2 1 1, and determinant is product iron value, so determinant value 2 non-zero. So for this matrix rank is 3, so rank of this matrix 3. Okay, the rank of this matrix A is 3, rank of H 3, right? The rank of H 3 since determinant non-zero. Okay, now the argument matrix is 3 goes 4 matrix. Okay, so its rank of AB will be less equal to minimum of m common means 3, 4. Okay, so minimum of less equal to 3, but since the matrix A has rank 3, so this implies its rank will be 3. Okay, this implies the rank of R will be 3. Its rank will be less equal to 3, but since the matrix A itself rank is 3, so rank of R is also 3. So rank of argument matrix is 3. So you can say rank of A equal to rank of argument matrix. The system is constant. Also it is equal to number of unknown, but number of column of A, So in this case, if rank of argument is equal to rank of A and equal to number of column of A, in this case we know the system has unique solution and the system is constant. Okay, so for k equal to 1, the system is constant. Now for k equal to -1, it is rank method. Okay, you can do both processes. Okay, now we are going to proceed for k equal to -1, and this is the last okay, last option. This is the last option left. K equal to minus 1. Option 3. For option 3, k equal to minus 1. Use k equal to minus 1, the system becomes, first system becomes 2x minus y will be 3. This first equation, x plus 2y equal to minus 1. This second equation, and minus y minus z, this will be minus 2. This means minus 1 minus 1 minus this y plus z will be 2, right? So this is the 3 equation, 1 2 3, and 3 unknown x y z. Okay, so this system has unique solution. There's number of equations, number unknown. So this system has equation has unique solution, and we are going to find the solution. Solve first two equation. If you want to solve first two equation, just eliminate x. So adding 1 with multiplying by 2, multiplying 2 and adding with 1, we get, what you get, 2x plus 2x minus y, 2x minus y equal to 3, and this minus 2x plus 4y equal to minus 2. If we add this out, so 3y equal to 1, so this is y equal to 1 upon 3. If you put y, if you get y equal to 1 by 3, then put any of the equation 1 and 2. I'm putting first equation, so I get 2x y plus 3, since y equal to 1 by 3, 1 by 3 plus 3, 9, 10 by 3. Okay, so this gives 5 by 3, so x is 5 by 3. So I get the value of x. If you get the value of x, then put y, value of y in third equation, you get z equal to 2 minus y means 1 upon 3, so 6 minus 5 by 3. Okay, so you got the value of z. So value of x equal to 5 by 3, y equal to 1 by 3, z equal to 5 by 3. So you got the unique value of x on y, z, x, y and z. Okay, so in this case the system is constant and system is unique solution. So k equal to minus 1 is possible. So k equal to minus 1 is possible value of k. Okay, so in this, so we have observed that option 1 is correct and option 3 is correct. Okay, so value of k will be maybe 1 or minus 1, but never 2 and minus 2. Okay, in this case k for k minus 1, you can also proceed for the rank method that I have done in the, for k equal to 1, for k equal to that I have done in the previous process. Okay, so you can also proceed in this method also. If you choose k equal to rank method, by using rank method, you can also conclude the system is unique solution. How? See, k equal to minus 1, then system matrix will be a minus 1 0, this b. I am writing the argument matrix. You have to basically show the rank of argument will be rank of a, then the system is constant. Okay, 2 minus 1 0 minus 1, this will be 3, k will minus 1 2 0 minus 1 0 minus 1, and this is minus 2. Okay, so you have to make it 0. So to make it 0, I am doing one thing, 2r2 plus r1. If I apply 2r2 plus r1, this operation, what do you get? This 0, 2r2 4 minus 1 3, this 0, 2r2 3 minus 2, this 1, 2 minus 1 0, this 3 minus 1 minus 1. Now make it 1. So take the operation 1/3 r2. If you apply the operation 1/3 2, then second row this entry becomes 1. So this becomes 1 0, this is 1 by 3. Okay, 0 minus 1 minus 1 minus 2, and 2 minus 1 0 3. Right, now you have to make this part to be 0. Okay, if a row form, so to make this 0, I am applying the operation to make it 0. I am applying the operation this r3 plus r2. If I apply the operation r3 plus r2, okay, so what do you get? You get the argument matrix AB equal to 0. This 8 this, so it becomes 0. This minus 1, 2 minus 6 minus 5 by 3, 1 by 3. This becomes 3, 0 1 0, and 2 minus 1 0. Okay, see, this is upper total matrix. So upper total matrix, since upper total matrix, so it will diagonal entry I holo, between diagonal entry I holo. Okay, so determinant will be product by I holo, so determinant will be 2 minus 1 minus 2, so determinant is non-zero. This is A matrix, right? And this is B vector. So determinant is non-zero since A 3 cross 3 matrix and determinant is non-zero. Okay, 3 cross matrix determinant non-zero. So we can say rank of A will be 3, right? Also the argument matrix will be 3 cross 4. Okay, we all know that for any matrix m cross n, we all know if A is a m cross n matrix, then its rank will be always equal to minimum of m comment, right? So for you can say for rank argument will be less equal to minimum of m, and m is 3, n is 4, so less equal to minimum of 3 and 4, so less equal to minimum 3. So its rank argument will be less equal to 3, but see the matrix is the inside the argument matrix. Okay, and its rank will be 0 non-zero, rank 3, so it implies rank argument will be 3. Okay, so rank of argument equals 3. So rank of argument will be rank of A. So you can say from this the system is consistent. The system is consistent. My system is solution. Okay, also it is number of column way, because number A has 3 column, 3 cross the matrix, so it is 3 column. Number of column. Okay, so rank of argument is equal to rank of A equal number of column way or number unknown. So in this case the system is unit solution. Okay, not only solution, in this case it is unit solution. So for k equal to minus 1, the system is unit solution. Okay, so in this question correct option are k, values of k will be maybe 1 or maybe minus 1. Okay, correct option are option 1 and option 3. So option 1 and option 3 are correct option for this question. Okay, so if you have any doubt, you can always ask in the comment section. Okay, and more video solution will come in the upcoming videos, and please subscribe my channel. And so thank you.